What up? What up? How's everyone doing? Uh, just making sure everything is good on my end. Guys, we're almost at 17K. Let's get to 20. Go ahead and like this video and follow along. It's going to be a good time. I've been thinking, I literally dreamt of these types of problems last night. And I looked at, I got inspired. I was looking at a lot of different videos. And particularly, I was looking at Black Pen, Red Pen. I don't know if you guys have ever seen his videos, but he is just amazing. And I saw a problem that I thought was really cool. That we're going to do today. But anyway, guys, like this video, follow along. I'm trying to get to 20K. We're going to do this together. But today we are going to do integration problems, a bunch of integration problems that I've seen in the past. There's students that have asked me these questions this week. So I think it's going to be really fun to go over these. I'm looking at the screen. I can probably make this a little bigger. How's everyone doing? What's everyone up to? I know it's Thursday, Friday tomorrow. Any fun plans? I'm here in Washington. The weather's really nice. Hopefully we can go we can do some snowshoeing, maybe some skiing. But what's everyone up to? Let me know in the chat what you guys are going to be doing. But I'm going to get started soon. We're going to do some basic integration problems in the very beginning. Just making sure all systems are good to go. Everything's showing good. All right. And if you guys have any questions or if you guys find any mistakes in my problems or in my work, go ahead and let me know, okay? I am open to criticism. Okay. Let's just start off with something basic, I would say. Let's do a cosine problem. So let's go ahead and talk about cosine of root x dx. And I saw this, I don't even know where it was. I think it was like an integration B problem for like University of Houston. And this was like one of the beginning or the intro problems, and I thought it was kind of fun because it has like a U substitution type problem that you kind of have to like do something different with it. Okay, let's go ahead and start off. So let's go ahead and make our U our root x, and our du is going to equal to 1 over 2 root x dx. Now a lot of people can already see how to simplify this, but I typically like to multiply the 2 root x to the other side so that we can have dx by itself. And so now we have 2 root x du is equal to dx. And then now I'm going to go ahead and put all those values in the new integral. So I have integral of cosine of u times 2 root x du. And this is why things get complicated here. If you guys all, or if anyone in the chat feels like they know what to do next, go ahead and let me know. And I'll try different methods. Or if someone has a different idea how to solve this, then please give me a heads up. All right. So for this one, because we have the 2 root x, we have to do something about it. All right. Now, of course, I do a lot of problems legacy. Okay. So let's look back. I'm going to circle this in red. Remember, u is equal to root x. All right, that's going to actually help us because we already have the root x there. That's exactly what I'm going to make this square root of x in the new integral that I have. All right, so now I'm going to have cosine of u times 2 u du. Yes, and I agree. Let's go ahead and move the 2 to the outside. That just makes things so much easier. So I moved the 2 and I put the u in the front, and now I have cosine of u du. All right. At this point, this is a very basic method that I think a lot of us are going to know. This is integration by parts. So let's go ahead and do that now. Okay. Yesterday, again, if you guys have seen any videos with Black Pen, Red Pen, he does something really cool. He's basically doing integration by parts. I'm going to do it the way he does it because I thought it was interesting. First time I've seen that, but I'm always open to new methods. So I'm definitely going to try this out. So my d, I guess this is the di method. It's basically integration by parts. So u, and then I have the integral of u, which is just du, I guess. And then I have cosine u du or I guess this is just cosine u, and then the integral is negative sine u. If I did that wrong, let me know. Again, I saw Black Pen Red Pen do this on YouTube, and I thought it was pretty fascinating. So now let's just go ahead and set it up. So I believe we start off with u cosine u. Nah, see, that doesn't work. Okay, I don't remember the DI method. I'm just going to go ahead and use integration by parts, just the way I'm used to doing it. Okay, so I'm going to do w is equal to u, and then dw is equal to du, dv cosine u, du, and then v is equal to negative sine u. All right, give me 1 second, guys. I have multiple screens and I'm responding to someone message me, and I had to respond really quick. Anyway, back to this integral. Let me go ahead and put this off to the right. So now I have 2 times uv, so it's going to have negative u sine u minus integral of negative sine u du. So I have negative 2u sine u, and then this is just going to be a minus plus cosine, no, minus cosine u, and then plus c. Samantha, just continue practicing. There's a lot of integration by parts on here today. Oh, I see what you mean, user. Yes. Or I'm sorry, Walter said it's not going to be cosine. It's not negative sine u. I got so distracted. Again, here I was trying to do like a different method that I saw online. Didn't like it. So I'm just going to stick to my guns. I'm going to stick to what I know. Okay, so he was saying that this, when you integrate cosine u, it should just be a positive sine u. So let me just rewrite our problem real quick. All right, guys, let's just finish this up. So I have u sine u minus integral of sine u du. There you go. And this is just going to become u sine u minus cosine of u plus c. There you go. Awesome. So don't forget, up on top in red, I have that u is equal to root x. So I'm just going to go ahead and put that in. And so I get root x sine of root x minus cosine of root x plus c. And that's the integral. Okay, that was the first one. This is just a warm-up. I'm going to make sure that I cross it off, because otherwise I'm just going to start repeating a lot of the integrals here. But anyway, okay. I actually just made a video on this next one. Kind of different, but I thought it was really nice. Okay, it looks like this. X times 1 minus x to the power of 2023. I don't know if you guys have ever seen like integration B videos, or just a bunch of they're just like integral competitions, which are actually really fun. But they always like to add this one, and whatever the year is, they put 2023, 2015, or whatever. But who can tell me in the chat what we should do? Where should we start this off? Anyone have an idea? Let's just try u sub. Okay. So let's go ahead and make u equal to 1 minus x. And now I take the derivative, so du is equal to negative dx. Okay, so let's just go ahead and put that on the other side. All right, so I have the integral of x, and then this 1 minus x was u to the power of 2023, and then our dx was negative u, or negative du. Okay. Let me just go ahead and rewrite this a little bit. I'm going to put that negative sign on the outside, make things much easier. But we still have this negative integral of x u to the 2023, which is kind of annoying, right? And then we have the du. But don't forget, this is where you have to be a little clever sometimes. And I'm going to go ahead and make, look at that, u is equal to 1 minus x. And then I'm going to subtract the 1 to the other side, so I get u minus 1 is equal to negative x. And then multiply everything by a negative 1 to get 1 minus u is equal to x. And that's going to help me substitute that in for this x here. So this is what I have. Negative integral of 1 minus u to the power of 23 du. Crispy, the algorithm knows. That's what it is. All right, let's continue. Let's go ahead and multiply the u to the power of 2023 to both terms. Now we can go ahead and do that. So we have negative integral of u 2023 minus u, what's that power? 2024 du. And now I think it's pretty simple. All we have to do is use the power rule. So we have negative, and then this is u to the power of 2024 over 2024 minus u to the power of 2025 over 2025. And then the plus c. Hopefully you can kind of see it on the window. If not, I'll write it at the end. Okay, let's distribute this negative sign. I'm going to do two things at the same time. I'm going to distribute the negative sign to both of these, and I'm just going to go ahead and plug in the 1 minus x back in for the u. So now I have negative 1 minus x to the power of 2024 over 2024 plus 1 minus x to the power of 2025 all over 2025 and then plus c. Awesome. All right, guys. This was nice. I know it's a little messy. Maybe I should write a little smaller because I guess everyone can see this. Let me move the screen just a tiny bit. I actually don't want to move it too fast. Maybe I can move this screen a tiny bit to the left. Okay. Anyway, let's go on to the next problem. Let me cross this one off. Where were we? I don't even know where it's at. I lost it. All good, though. Oh, I see where it's at. Okay. All right. This is one that kind of confused me in the very beginning, but let's try it out. I have the integral of root 7 minus x times x minus 1 dx. Okay. Who can tell me in the chat what we should do? Any recommendations? I think the first thing, whenever you have something like this, obviously a little complicated, let's just go ahead and distribute this using the FOIL method. Ooh, Owen said u sub, but I'm curious how that's going to work. Owen, if you feel like you know what value for u we should do, go ahead and let me know. Okay, so now I have the integral of, let's go ahead and do, this is 7x minus 7. I will do that, Tommy, okay? And then let's go ahead and do plus x. I believe that is correct. Okay, so Tommy said go ahead and write this to the power of 1/2. I'm going to do that soon. Actually, let's do that in this next step. All right, so now I have negative x squared plus 8x minus 7 to the power of 1/2. Okay. Any other suggestions? Anything that people think we can do? So we wrote it as a radical. Doesn't really help us here, at least so far. Okay. There's one thing I absolutely hate, and I hate doing this all the time, but we are going to use completing the square. I don't like completing the square. U sub the quadratic. Okay, so think about what that would do. So if you tried that on your own on a piece of paper, we're going to get some issues there. Okay, but here's what we're going to do. We're going to go ahead and use completing the square. Okay, so the first thing that I'm going to do is I'm going to factor out a negative from this x squared. And I have an 8x. And now I'm going to go ahead and complete the square. How do we do that? Don't forget, we take that negative 8 divided by 2 and then square it. And that's going to be positive 16. So we have plus 16 inside the parentheses, and then minus 7 and then all to the power of, whoops, not yet, because I introduced a positive 16. Don't forget that I technically introduced a negative 16, so I need to put a plus 16 on the outside here. Okay, so now this whole thing is to the power of 1/2. All right, so let's go ahead and rewrite this. So far, this becomes negative x minus 4 to the power of 2, and then negative 16 plus 6, or negative 7 plus 16 is positive 9, I believe. And now we are good to go. Okay, not bad. So let me go ahead and just rewrite this so far, just because I have that negative in front of the x minus 4. So I'm going to do 9 minus x minus 4 to the power of 1/2. A lot cleaner, I would say. Who can tell me what we have to do here if we're trying to integrate this? Let me know in the chat if you feel like you know what to do. While I do that, I'm going to go ahead and shrink this. Whoops, didn't mean to do that. Sorry. There we go, much better. You're going to see what I mean. Let me go ahead and shrink this so we can create some space on the blackboard. All right, here we go. All right, so the next step that we're going to do is trig sub. I don't know if you guys have covered trig sub. Let me know in the chat if you have. Otherwise, we're going to do it right now. And this is the way it's going to work, okay? So it looks like we have a 9 minus x minus 4. A lot of people will run with it right away and say, okay, x is going to, or theta is going to equal to x minus 4. But let me go ahead and show you how this works. So when we use trig sub, we're going to go ahead and create this triangle. Okay, so we have this theta. And then we have this 3 on top. And then we have an x minus 4 on the bottom. You're going to see why I even did that. Whoops. Okay. And then so this side over here is going to be 9 minus x minus 4 squared. Who can tell me how I got that? This is, I use Pythagorean theorem here. Yes, so definitely 9 because it's the square root of 9. That's how I got the hypotenuse is 3. And then on the triangle, I technically used Pythagorean theorem. Okay, that's how I got that 9 minus x minus 4 squared. Okay, so let's go back to this. Why am I even doing this? All right. One thing that I'm going to do is, I guess we can say that, oh, shoot. Okay. I'm just going to run with this because I kind of already messed up, but whatever. We're going to do this. Cosine of theta is going to equal to, if we're looking at the triangle, this is equal to x minus 4 over 3 because adjacent over hypotenuse. Okay, I'm going to go ahead and multiply the 3 to the other side to get 3 cosine theta is equal to x minus 4. And then I'm going to go ahead and integrate this. So this is going to be 3 or negative 3 sine theta is equal to negative 3 sine theta d theta is equal to dx. That's going to be prove helpful. Okay, so let's go ahead and use this idea for our integral. So we have integral of this 9 minus x minus 4 squared that I'm trying to rewrite. If I look at the triangle that I have on the right side, I can technically do sine of theta is equal to opposite 9 minus x minus 4 squared over 3. So if I multiply the 3 to the other side, I really have 3 sine theta is equal to root 9 minus x minus 4 squared. So 3 minus sine theta is this entire value. And that's my new integral so far. So I'm going to have 3 sine theta times, what's my dx? Let me go ahead and highlight that in green. It is that value right there, negative 3 sine theta. So let's go ahead and do negative 3, So times negative 3 sine theta d theta. And now if I multiply the 3 and the negative 3, I get negative 9 integral of sine squared theta d theta. All right. Now, it looks a little more complicated, but honestly, it's going to make a lot more sense soon. Who can tell me, or someone in the chat, if they know how to integrate sine squared theta? Let me know. And I'll give you a hint. It's definitely 100% a Pythagorean identity. Anyone remember the Pythagorean identity? Double angle cosine 2x. Ooh, cosine something, 1 minus 2. Yes, there you go, Charles. I believe you're right. So it's this one. Let me go ahead and write it in red. Sine theta is technically root 1 minus cosine 2x all over 2. So if I square both sides, I get sine squared theta is equal to 1 minus cosine of 2x over 2. Yes, there you go. Okay, so I'm definitely going to have to create some space on the blackboard here so I can go ahead and show all my work, but let me go ahead and make this smaller. Damn, the integral started really easy and then it just got way more complicated. Okay, so now what I have is -9 integral, and now I'm going to rewrite that sine squared that we're looking at. It's 1 minus cosine of 2x all over 2. Whoops, I should continue using theta. 2 theta all over 2 d theta. And now because it has a common denominator of 2, I can rewrite this as -9 integral 1/2 minus cosine 2 theta over 2 d theta. All right. Yeah, someone said take the 2 out. Why not? Let's just do that, right? Instead. So let me just go ahead and rewrite that. Honestly, I don't really care for the fractions that much, but yes, let's just do that now. So people were saying that because we have the 2 on the bottom, let's remove it. So then we have -9/2 integral of 1 minus cosine 2 theta d theta. Okay, so now we're going to go ahead and integrate this entire thing. The first value, the 1, is just a power rule. It's just going to be theta. And the other one, it's going to be a u substitution. But I'm just going to do that. This is going to be behind the scenes, technically. So I have -9/2 theta plus sine 2 theta all over 2. And then we have the plus c. So this is our integral so far. If I distribute that -9/2. -9/2 theta minus 9 sine of 2 theta all over 4 plus c. Okay. Now, I'm not going to do this now. I definitely want to touch on other problems, but we're technically not done here because we have to rewrite the entire problem in terms of x. So we have to go ahead and use the trig stuff that we had up on top. Give me a thumbs up if you feel like I should actually complete it or just move on to the next one. So move on to the next one, let me know, or give me a thumbs up if you want me to complete the entire thing in terms of x. I'll take a sip of my LaCroix. Okay, so I see a thumbs up, next. Ah, shit. Okay, well, thumbs up, next. Okay, I feel like it's 50-50. I wonder if I could even do a poll. Next time I'll do that. Next. Oh, okay. If I get 2 thumbs up in a row, I'm just going to do it. Otherwise, if I get 2 next in a row, I'm going to go to the next problem. I see a next. Shoot. Okay, Scorpio and Jack's bitch said thumbs up. I'm just going to complete it. Okay, so let me make this smaller, then we'll go on to the next one. All right, be patient. I'll be quick, I promise. Okay, so let me make this smaller. Jeez, I love how these just continue to get even smaller. Okay, maybe, and then I got to move this one. Okay, I guess I can't even erase that. All right. So this was my problem. -9 2 theta minus 9 sine 2 theta over 4 plus c. So don't forget, we had a couple things. I know it's kind of hard to see now, but we had that cosine theta was equal to x minus 4 over 3. And we also had that, I guess from here we can say that theta is equal to arc cosine of x minus 4 over 3. And then we also had that sine theta was equal to root 9 minus x minus 4 squared all over 3. Okay. I promise. I'll be quick. Okay. So negative 9 theta, or negative 9 halves times theta, that was the arc cosine. X minus 4 over 3 minus 9 over 4. Sine of 2 theta is technically 2 sine theta cosine theta. So this is 2 times sine theta. So root 9 minus x minus 4 squared over 3 times the cosine theta, which is x minus 4 over 3. Okay, as you can tell, it was that difficult. Guys, I did the next one, or I continued, and the amount of people watching just dropped. I got to go to the next one. I'm so sorry. Jesus. We were like at almost 200. Okay, let's do the next one. Let's do one that's not as difficult. I think everyone can solve this one. Okay, integral of e to the 4x all over root e to the 2x plus 9. Do we want that one? Yeah, we want that one. Okay, so who can tell me what our first step should be? Anyone have any ideas what we should do first? Make 2 integrals with the Jacobian. Okay, to be honest, I have to look into that further. I don't even want to do it live because I will be messing up bad. Okay, let's try one that I'm hoping that some people might know. Okay, how about this one? Hold on. Okay, let's do a softball for a lot of people. Okay, so let's do integral from 1 to 4 of e to the root x over root x, okay? Let's start off small, kind of, get us in a rhythm, and then we'll go to the next one. All right, so who could tell me what we should use? Okay, I see Ethan said u should equal root x. I kind of agree. Let's go ahead and do that. U is equal to root x. All right. Dora Cohen, definitely integration by parts. It'll come soon. So let's go ahead and do du is equal to 1 over 2 root x dx. Let's multiply the 2 root x to the other side. Which, by the way, guys, if you don't have the derivative of root x memorized, you gotta. It's so easy to do, and it definitely saves you a lot of time. So 2 root x du is equal to dx, okay? So let's go ahead and put that back into our integral so far. So I have integral of e to the u, but then I have root x times 2 root x du. I think this is much easier. Look at that. The root x cancels out, just what I wanted, but then the 2 is on the outside. So I have 2 e to the u du. What happened to my parameters? I didn't write them yet. Who can tell me why? I definitely have to rewrite them, because if I write 1 and 4, that is incorrect, because these are in terms of x. These are not the parameters. Our integral is now in terms of u, so I have to make sure that I change those values for u. How are we going to do that? So again, look up on top. We have u is equal to root x. Very helpful. So if I focus on the bottom parameter, which was 1, when x was equal to 1, u is equal to root 1, which is 1. And then if I focus on the 4, whoops, looks like I erased it. If I focus on the 4, when x is equal to 4, u is equal to root 4, and that is equal to 2. So look at my new parameters. These are from 1 to 2. All right, very quickly, who can tell me the integral of e to the u? Quarth, don't worry, dude. You just got to continue to keep up. Trust me, they get really fun. This is all fun and games, man. This is entertainment. Yes, so everyone's saying that the integral of this is e to the u. That's exactly what I'm going to do. And I'm applying the first fundamental theorem of calculus. So I have 2 on the outside, e to the u, and I still have my parameters 1 and 2. And now all we do is plug in the 2. So that's 2 e to the 2 minus, and then we plug in the 1. I like to show all the steps because someone might get confused, and we just got to be careful with that. All right. So 2e to the 2 minus 2e. That is our solution. No plus c here, Ethan. No plus c because we are not doing an indefinite integral. We did a definite integral. All right. Give me a thumbs up if you've seen Black Pen, Red Pen on YouTube, or if you guys follow him, because he did an amazing integral that I was looking at in his previous 100 integrals, and that dude did something bizarre, and I'm like, no way. I thought it was super clever. Would have never thought about doing that problem. Anyway, let's go to this next one. I'll cover that one that Black Pen, Red Pen did. Yeah, I love that guy. He is amazing. Anyway, okay. Let's go to this integral of secant cubed. Let's just do x dx. All right, as I'm doing this, guys, or as someone is telling me what I should try to do, don't forget to follow. We're almost at 17K followers. Let's get to 20. Okay. Any thoughts? Okay, Ethan said u is equal to cosine x. Okay. Integration by parts I'm seeing. I don't know. This is curious, right? Or again, if you guys have a piece of paper, pull that out, start writing it down, play along. So this is secant. This is like 1 over cosine. If, you know how cosine of x is equal to, adjacent over hypotenuse? So secant of x is a reciprocal of cosine, and that's hypotenuse over adjacent. Okay. Now I'm looking for the right answer. So Squid and Jack was saying split this, and I kind of agree. So we're going to do secant squared x times secant x dx. That's what we're doing first. All right. Now, why are we doing this? Because secant x is a very unique identity. Okay, who can tell me what that is? What is the identity of secant squared x? Not 1 plus tangent, but 1 plus tan squared. I think that's what everyone's trying to say. So 1 plus tan squared x secant x dx. All right. So now we're going to go ahead and distribute everything. And now we get to 1 plus, not 1, secant x plus secant x tan squared x dx. Okay. At this point, we're not even going to worry about that integral of secant x. We should just have that one memorized. There's a whole proof for that. We're not even going to worry about that today, okay? But we know for sure that first integral is going to be just natural log of secant x plus tan x. But let's talk about this next one. That second term, people are saying, I think, to split 1 cosecant squared x, make u equal to secant x. Okay, let's try that. Okay, make u equal to tan x. Rewrite tangent as sine. Oh, geez, so many ideas. Okay, I actually don't remember the answer to this one, so we're just going to have to kind of work it out on the fly. Or is it something else, guys? Why do I have a feeling it's something else? The derivative of tan x is secant squared x. Okay, so let's try to use substitution. Okay, u is equal to tan x. Du is equal to secant squared x dx. That's not going to really help us cancel out. So it looks like we might have to try something else. Okay, let's try secant x is our u. So du is equal to secant x tan x. But that also doesn't help us things cancel out. Anyone else? Okay, so it doesn't seem like that's gonna work out, guys. Anyone else? Oh, I see Tyler's on the chat. Tyler, why don't you school us on this? What do you think? What should we do to this? So someone said rewrite tan squared x as what? Tyler's on the right track. We're going to use integration by parts. Definitely integration by parts. Okay. So let's go ahead and use integration by parts. So if that's the case, guys, if we use integration by parts, so we need our u, and then we need to find our dv. So what's our u? What do you guys think? What is our u value? Okay, let's try some stuff, right? I don't really know the answer to this, but let's try it. So secant x. So that means du is secant x tan x. But then what about our dv? Guess I don't have room for this. Hold on, let me just make this a little better. So u is equal to, whoops. So u is equal to secant x, du is equal to secant x tan x dx. Okay, that would mean that our dv is going to be tan squared x. Does that work? If we make our dv equal to tan x, will that work, guys? What do you think? Okay, so it seems like a lot of people are having some difficulty. Let's see if Tyler's still here. Let's see if he can tell us. Guys, if you don't know Tyler, he is the man. Wallace Stem. You guys got to go follow him. Secant cubed x. Anything else? Okay, so let's see Wallace Stem, guys. He's telling us, okay, so tangent is secant x to dv. Okay, so let's see. Jacob, let's try that. All right, so we're going to make, yeah, this one's a little tricky. I covered this with a student yesterday, and he said that his calc teacher said, you just got to memorize this. That's simple. Okay, so a lot of people are suggesting this, or what I'm seeing is we're going to rewrite this second part as secant x, and then tan x, and then another tan x. Okay, so that means that our u is tan x, and that makes our du secant squared x. And then our dv is equal to secant x tan x, and that makes our v equal to secant cubed x. Or secant squared x, I'm sorry. Or just secant x. Wow, that was terrible. All right, so let's go ahead and create some space here on the blackboard. And let's see if what people were suggesting, if that is correct. All right, let me go ahead and make this smaller. Okay, so that first integral, that again, we said that was pretty simple. I mean, we won't worry about that one just yet. But this second one is going to be secant x tan x minus integral of secant cubed x dx. Guys, we're back. We're back on the same thing. That secant cubed x. Did I do something wrong here? Or did that integration by part not work? Okay, Wallace, go ahead. Wallace wants to duet, guys. You guys down? Let's do it. Wallace, I think you're going to have to... let's do it. Hold on. Wallace, you're going to have to... request me real quick. Let's see. Yeah, if you can, that'd be great. Guys, this is exciting. Wallace Stem is going to get on here and explain it for us. Okay, he's going to start his live soon. And let's see what he's got. Ethan, I'm trying to use... Okay, so Ethan's saying use integration from parts on secant squared x. But where's the secant squared x? Okay, let's go ahead and try this. All right, hold on. Let's go ahead and try this real quick. Oh, shoot, I erased everything, guys. Okay, so other people are just saying that use that integration from parts on this part up on top. Okay, so let's see if we can do that. So that means that you're saying our u is equal to secant x, du is equal to secant x tan x, and then our dv is equal to secant squared x, and our v is equal to tan x. Is that what you were saying, Ethan? Okay. No, Irvin, we're not giving up. Okay, so you're saying our u should be secant squared x? Okay, I tried the integration from parts. That didn't work. Let me just rewrite this real quick. Whoa, shoot. Okay. Wallace, all good. We'll try another one. We should plan for one, dude. We should plan for an integration, just a powwow, just to redo this. Okay, hold on, guys, because I'm trying to, I guess I'm reading the chat, and I'm like trying to take advice from too many people here. Okay, so let's go ahead and rewrite this real quick. Okay, this is where I am, because a lot of people are suggesting to listen to Ethan here. So we're going to rewrite this as secant squared x, and then secant x dx. Okay. All right, guys, I'm only going to listen to Ethan because he's over here. He is adamant that this is where we continue to use integration by parts. Okay, what do we make u? Okay, so he said go back to what you had, which was 1 plus tan squared secant x dx, and that was secant x plus secant x tan squared x dx. This is what I had. What's everyone thinking? Oh, now I went further. That's what I've been telling you. Okay, so look, this is where I'm at. So you're saying I should stop here. Bro, this is exact. Look, I'm not stopping. Okay, so should I distribute this secant x? Okay, so let me go ahead and distribute the secant x. Okay, this is where I'm at. And do integration by parts in this second term, right? Okay, so I'm definitely doing integration by parts. This is exactly where we were. Okay. So what will my u be if that's the case? Okay, guys, look, I'm going to separate the integrals. And I think maybe everyone's getting confused on that. So it should be integral of secant x dx plus integral of secant x tan squared x dx. Okay, hope that makes more people happy with that. Okay, let's separate tan x. So far, every word that has come out of Ethan's chat is trustworthy, I would say. Okay. Okay. All right. Hope I'm not being trolled, because that's exactly what I did. Okay, so let me just make this smaller. Forget these integrals that I did. Let me just put that here. Okay. So, okay. So let's see. U is equal to tan x. Du is equal to secant squared x dx. And then dv is equal to secant x tan x dx. And then v is equal to secant x. Yeah, Cam Foster, maybe I'm just reading too much. I should stop just reading the chat like this. All right, so let's see. Let's go ahead and rewrite this. So the first one, it's secant x dx, and then now I have plus uv, so secant x tan x minus v du. And this is what I keep saying, that we're back in secant cubed x. All right. So now we're gonna listen to Oscar, because we did everything correct here. Okay, so for this, let me just create a little bit more space, because we're gonna be done. Don't forget that this whole thing, okay, this is the tricky part. This entire thing is just equal to secant cubed of x. Okay, it looks like I have some integrals that I need to rewrite. So remember, this whole thing is equal to integral of secant cubed of x dx. So one thing that I did not write, and then we're going to add the secant cubed of x dx to the other side. And so now we have integral of secant of x plus secant of x tan x is equal to 2 integral of secant cubed x. Ethan, you're the man. I apologize. Yes, and Tyler, we got to get together and do something like this, man. Okay, and then remember, like we said, this integral of secant x, we're not even going to talk about how we solve that. We just should know that this is natural log of secant x tan x. And then plus secant x tan x, the entire thing divided by 2 plus c. There you go. All right. Okay, let's go ahead and do another one. All right, Tyler. Talk soon. Off the rails math. Yes. All right, guys. Let's try a different one then. Let's go ahead and do integral of 1 over 4x squared plus 4x plus 4. Okay, no more secants right now. Everyone's got to thank Ethan and Tyler. Who else was yelling at me over here? I think it was Jason. So many people. Oscar. Gosh, guys, that was fun. That was really fun. Okay. So someone said, let's go ahead and take out the 4. And someone's saying partial fractions. I think that's going to be true. Let me move. I realized that I shouldn't have that. There you go. Much better. Okay. So let's go ahead and factor out a 4 from everything. So we have a 1/4 integral of 1 over x squared plus x plus 1. Okay, someone said partial fractions, but if that's the case, if we're going to use partial fractions, we are going to have to factor the bottom out. But can we even do that? This is calculus 2, by the way, or I guess you can say calculus 1, calculus 2, or calculus 3. Complete the square, Oscar. Oh, man, I hate completing the square. But yes, I absolutely agree that we're probably going to have to complete the square. Okay, so let's go ahead and do that. 1/4 integral of 1 over x squared plus x. And how do we complete the square? We're going to divide the 1 by 2 and then square it. And that's going to be 1/4. Okay, so I put a plus 1/4 there. We still have the plus 1. But because I introduced the 1/4, I'm going to have to subtract the 1/4 from the bottom. All right, so let's go ahead and see what this turns to. I have 1 over x plus 1/2 squared plus 3/4. Nasty. That is very nasty. All right, all good though, but you're absolutely right. This is gonna be an arctangent problem, and the way this works, if you don't know arctangent, it's a very common problem that you see. And we make our u equal to x plus 1/2. Our du is equal to just dx. And we also need the a squared value, or the a value. Okay, Dor, we needed to complete the square because if we couldn't do partial fractions. This couldn't factor out, so we had to use completing the square. Okay, so a squared is technically equal to 3 over 4. So a is equal to root 3 over 2. And so now my problem looks like this. 1/4 on the outside, 1 over u squared plus root 3 over 2 squared du. And that helps us rewrite the integral and kind of understand, okay, this is going to be an arctangent. So we have 1/4 times. And remember, arctangent has 1 over a. So this is 1 over root 3 over 2. Arctan of x plus 1/2 divided by root 3 over 2. Okay, let's just go ahead and rewrite this. This is, looks like 2 over root 3 arctan of 2x plus 1 over root 3. And don't forget your plus c. Yes, Louise, I will write down the formula for arctangent. Here, I would do it right here. So if you have an integral of 1 over x squared plus a squared, I guess I should use u instead, not dx. So this is equal to 1 over a arctan of x over a plus c. Hope that helps. All right, thumbs up if you guys want to do another problem. Should we do one with partial fractions? It seems like everyone is really down for that. Okay. Let me know if you guys are down for a partial fraction integration. Go ahead and give me a thumbs up or no if you don't want to. We can do another one. Yes, a lot of different formulas. You just have to get used to the one, that you feel most comfortable with. All right, Ethan, take it easy. All right, so let's go ahead and try. All right, let's go ahead and do a, all right, seems like a few thumbs up. Let's go ahead and do a partial fractions problem. Okay, so let's go ahead and do this one. It's going to be x squared over Let's do x squared plus x minus 6 dx. Oh, okay, after this one, yes, and I would do that one. After that problem, and that will be my last problem because I do have to head out after these last two problems. Okay, so who can tell me what we should do first? It looks like we have an integral. The degree of the top is the same as the degree of the bottom. So what do you guys suggest that we do? Okay, so Dora's saying go ahead and rewrite this on the bottom. We are going to factor this out, and this is going to be x plus 3, x minus 2. Okay. All right. And this is true. We are going to do partial fractions, but the thing about this is that because the degree is equal to the bottom, the degree of the top and the bottom are the same, we have to divide. So whenever the degree of the top is larger or it's the same as the bottom, we have to divide first, and then we're going to be able to use partial fractions. So this is going to look just like this. We are actually going to divide x squared divided by x squared plus x minus x, or minus 6, and then we're just going to use a partial fraction. So we're just going to multiply by 1. So that's going to be x squared, and then plus x minus 6, and we're going to subtract this. So negative 6 plus 6. So this is actually our new integral. It's 1 plus negative 6, or negative x plus 6, all over x squared plus 6 minus 6 dx. Okay, and then from there, we're going to go ahead and use partial fractions. So let me just make this smaller. Okay, I don't catch all the things here. Okay, and guys, if you're taking calculus and haven't done a long division, start getting used to it now. All right, so just to rewrite this, I have integral of 1 plus, and this is where we're going to use the partial fractions. I'm going to rewrite this as x plus 3, x minus 2 dx. All right, so we're going to split this into, technically this is a over x plus 3 plus b over x minus 2. And if we try to get common denominators, this will become a times x minus 2 plus b times x minus 2, technically all over x plus 3 times x minus 2. And this should equal to negative x plus 6 over this factor. Okay, so we don't really care about the denominator because we already took care of it. That's the whole point of partial fractions. What we care about is the top. So a times x minus 2 plus b times x, well, I put a x minus 2, it should be x plus 3. The b should be an x plus 3, is equal to negative x plus 6. So let's go ahead and multiply these things, or distribute the a's and distribute the b. So I have ax minus 2a plus bx plus 3b is equal to negative x plus 6. Okay, someone said they couldn't see the right side. Hopefully that kind of helps. Yeah, the pair for b, I think it was x plus 3, right? Did I fix that? Okay, so let me know if I think I fixed it. Okay, cool. Just making sure. All right, so then now, because we have the common like terms, or the like terms there, I'm going to go ahead and put a plus b times x, and then plus negative 2a plus 3b is equal to negative x plus 6. Now, the reason why we did this is because now, look at the coefficient for the x. That's a plus b. So then a plus b should equal to the coefficient for the x on the right side. So that's negative 1. And now let's look at the coefficients for the bottom here. Negative 2a plus 3b is equal to the constant on the right side, so that's equal to 6. All right. How are we going to solve this? Systems. So if you thought in Algebra 2 and Pre-Calculus you were done with systems, woo, you were wrong. We always cover them. Okay, so there's a few ways of doing this. I'm just going to multiply the top equation by 2 because I want to get rid of my a's. It doesn't matter which one you do, but you get 2a plus 2b is equal to negative 2 over negative 2a plus 3b, and that's equal to 6. Yes, partial fractions are really, really helpful. Okay, so now let's go ahead and add vertically. So the a's cancel out, and we're left with 5b is equal to 4. So b is equal to 4 over 5. Hope you can see that on the bottom, but don't worry, I'll make this smaller for us so that we can see everything. Okay, so 4/5 is the b value, and now we just got to find the a value. Well, remember, a plus b is equal to negative 1. So a is equal to negative 1 minus b, or negative 1 minus 4/5. And that's going to be negative 9/5. Okay, so let me make this smaller so that we can see everything. And then we're almost done. And then someone requested one final integral, which I'll do at the end, and then we're going to call it. But again, guys, please continue following. I'm going to try to do this twice a week, just doing fun integrals, and I'll take requests. If you guys want to do derivatives, if you guys want to do some other problems, let me know, okay? Okay, so this is what we have so far. We have integral of 1 plus, and then according to our partial fractions, the negative, or the a value was negative 9/5 over x plus 3, plus our b value, which is going to be 4/5 over x minus 2 dx. Yeah, I can do Calc 3 stuff. We can do like what, partial derivatives, or we can do like saddle points. We can sometimes do like, double integrals and all that stuff. All right, so the final problem here is integrate 1, which is just x, minus 9/5 natural log of x plus 3 plus 4/5 natural log of x minus 2, and then plus c. Boom. That is our value. Harry, I don't know at what age. I mean, it all depends. Personally, I did it when I think I was 15, but some people do it later. It all really depends. All right, so let's go to that I'm going to do one more problem, okay? Let me go ahead and erase this for us, okay? And then we're going to do one more problem that I had written in the very beginning, and I said that we were going to do after. Oh, I didn't get to the problem that Black Pen, Red Pen covered, but I'll do that next time. Okay, so this is integral of e to the 4x over root e to the 2x plus 9 dx. All right, guys, final problem for the day. Who can tell me where we should start? Fourier transform. I'll try. Okay, so someone's saying u sub. All right, what should the u sub be? Okay, so someone's saying that e to the 2x plus 9 should be your u sub, that entire thing. Okay, so let's try that. U is equal to e to the 2x plus 9. So then when I take the derivative of this is du is equal to 2 e to the 2x dx. Okay. Hasanabi? No, man, don't look like him at all. I don't have the long hair. I don't have the shoulders. Don't have the big hands. No way I look like Hasanabi. All right. So that looks like du is equal to 2 e to the 2x dx. So let's go ahead and divide the entire thing to the other side. Okay. So let's see. It looks like it's conflicting values, but let's try this. Let's see if this works, guys. So I got integral of e to the 4x, which we'll talk about in a second, and then over root u times du over 2 e to the 4x. Okay, so I have the 1/2 on the outside because the 2 is in the denominator. Whoops, on the bottom I had e to the 4x, but it's really e to the 2x. Okay, so what's going to happen? The e to the 4x and the e to the 2x are definitely going to combine, and we're going to subtract the powers there. So this is going to be e to the 2x over root u du. But it seems like I have an issue here. I need to take care of that e to the 2x. Well, again, let's look up on top. U is equal to e to the 2x plus 9. So if I subtract the 9, I get u minus 9 is equal to e to the 2x. And so I can go ahead and substitute that in for the e to the 2x on that side. So let's see what that gives us. 1/2 integral of u minus 9 over root u du. All right, okay. This is really easy. Once you have only one term on the bottom, you can just go ahead and combine these things. Let me just, again, create some space on the blackboard. Guys, we write so much here that we just have to continue to make these things smaller. Okay, so let's go ahead and rewrite this. First thing that I'm going to do is I'm going to rewrite the root u into u to the 1/2 du. And I'm going to separate this. Check this out. I'm going to have two separate integrals. One of them is going to be u over u to the 1/2 minus 1/2 integral 9 over u to the 1/2. Okay, what do you guys think I should do with that first term? I should definitely combine it. What do I do to the powers? Definitely simplify. Definitely subtract. Let's go ahead and do that. 1/2 u, integral of u to the 1/2. Now, that first one, how did I turn that into u to the 1/2? Well, u has a power of 1 on top. U to the 1/2 is on the bottom. When we subtract this, this is u to the 1 minus 1/2. So u to the 1/2. All right. And then minus 9 over 2, integral of u to the negative 1/2 du. That second integral, all I did was bring the u to the negative 1/2 on top. Okay, and you're right, that du is missing. Honestly, that it's like at that point, we're just trying to make sure we write everything correctly. You're right. Thank you for that. Okay, at this point, all we really do is just use subs or power rule for these things. All right, so now we have 1/2 u to the 3/2 divided by 3/2 minus 9/2 u to the 1/2 divided by 1/2 plus c. Okay, I want to do, because this is the last problem, I definitely want to do it justice and just create more space on here so it could look a lot cleaner. All right. Okay, so I had that 2 that was on there. All right, guys, let's talk about how that first one simplifies. This is going to be 2/3 times 1/2 u to the 3/2 minus 9/2 times 2 over 1 u to the 1/2 plus c. And obviously a few things cancel out. Okay, I'm going to do a couple of things. The first one, I'm going to cancel out the 2's from the top and the bottom. And then I'm going to cancel out the 2 from the top and the bottom in that second term. And now I'm just going to rewrite everything with the u value. Okay? Yes, I will wait for the screenshot. Give me 1 second, okay? So let me just rewrite everything in terms of x now, because up on top, don't forget that u was equal to e to the 2x plus 9. So this is 1/3 e to the 2x plus 9 to the power of 3/2 minus 9 e to the 2x plus 9 to the 1/2 plus c. All right, everyone take your screenshots. Once that's loaded, I won't erase it, okay? I'm just going to end the live pretty soon. But anyway, I hope you guys had fun. That secant cube dex was really fun. I'm sorry for trolling you guys, but thank you to Ethan. Thank you to Oscar. Thank you to all you guys for holding me accountable. Anyway, I hope you guys are liking these videos. Please follow me on here. I'm trying to get to 20K. Let's do this, guys. Follow me on YouTube. I'm posting more long-form content on there. And I think maybe tomorrow, if not for sure next week, we'll do some more integrals. But if you guys want to cover anything, let me know in the comments either in here or any of my videos. I try to save them as much as I can. I'll save those videos or save the comments and put them on my favorites. And we'll review those things. All right, guys. Wish you all the luck. If you guys have a test tomorrow, good luck. If you don't, well, then keep studying. All right, take it easy, everyone.